Now, in this video, we're going to take up one more problem on shaft, the problem number 29. A hollow shaft is as shown in the figure. If the allowable shear stress in the shaft material is 60 MPa, determine the maximum power transmitted by the shaft at 200 RPM. Also, find the length of the two sections if the angle of twist produced in two sections of the shafts are equal. So we have a shaft having diameter 40, and there is an internal counter bore of diameter 30 to a depth of L2, and also the diameter of 20 for the entire cross section, and that entire length, but that diameter 20 for a length of L1. So we have determined which in terms of A, B, and C having a shaft length of 1000 mm. So tau is given, which is 60 Newton per mm square, and N is 200 RPM. And the maximum power what we need to calculate is torque at the section AB, that is TAB. So that is torque between A and B, which I need to find out. So this will be a shaft having length L1 and hollow shaft of length L1 having internal diameter of 20 and the external diameter of 40. So TAB will be equal to pi by 16, that is pi d cube by 16 into tau, which is the general formula for the shaft, which is pi by 16 into the outer diameter is 40, so 40 to the power of 4 minus internal diameter is 20 to the power of 4 divided by d naught, that is 40 into tau, which is 60 Newton per mm square. On simplification, we will going to get TAB will be equal to 706.86 into 10 to the power of 3 Newton mm. Now, when you are considering for the task of the section BC, which will be TBC, will be equal to pi by 16 into, now in this case, the outer diameter is 40 to the power of 4 minus internal diameter is minus 30 to the power of 4. Close the bracket, divided by 40 into 60. So on simplification, you will going to get the torque on BC will be equal to 515.42 into 10 to the power of 3 Newton mm, because converting directly into Newton mm. So therefore, the maximum permissible torque is the smaller among the two values. So the maximum permissible torque will be equal to 515.42 into 10 to the power of 3 Newton mm. So that will be equal to 515.42 Newton meter. So the maximum power transmitted by the shaft capital N will be equal to 2 pi NT by 60,000 kilowatt. So that will be equal to 2 pi into N is 200 into 515.42, because we need to have it in meters only. So divided by 60,000 will be equal to 10.8 kilowatt. So the length of two portions, what I need to find out. So given that the angular twist in both the sections will be equal, so theta AB will be equal to theta BC. So therefore, TAB into length of AB divided by G into JAB will be equal to TBC into LBC by G into JBC. So G is same for both the sections. So here T into L1 divided by G into pi into 40 to the power of 4 minus 20 to the power of 4, close the bracket, divided by 32 will be equal to T into L2 by G into pi into 40 to the power of 4 minus 30 to the power of 4, close the bracket, by 32. So G gets cancelled. So on further simplification, L1 will be equal to 1.37143 into L2. Also we know what is that L1 plus L2 will be equal to 1000. So we know L1 is 1.37143 into L2 plus L2 will be equal to 1000. So L2 will be equal to, on simplification, you will go to get it as 421.7 mm. So the length of the portion BC, LBC will be equal to L2, which will be equal to 421.7 mm. And length of the portion AB, LBB will be equal to, that is L1 will be equal to 1000 minus 421.7, which will be equal to 578.3 mm. So this is how you will be able to analyze and solve this particular problem. Thank you.